cheap solar power, batteries, and electric vehicles are changing the transport and energy sector as we know. I bring in guests to this podcast who will help you with their ideas to navigate this energy transition. By the way, this episode is also available as a video on our YouTube channel. Just search Energypreneurs. Thank you for joining. Hi, good morning, Bruce.
Good evening from California.
Okay, I'm in Manila, so it's a completely other part of the world, and technology makes it possible today. Amazing, and for free too. Maybe you can start introduce yourself first.
Yeah, so I was with Lawrence Berkeley National Laboratory for nearly 4 decades in California. It's the Department of Energy National Laboratory in the United States, working on building energy efficiency and in more recent years, demand flexibility. And my goal is to, for electricity, what the internet protocol did for communications, help us move to a completely different model for how we do it that is much better than the 19th century model we do today.
Wow. Can you explain a bit more then? What are the building blocks? What are we talking about?
Yeah, I grew up in Silicon Valley, and so I was not involved in, but I watched internet technology being born. I had very early experiences with both computers and networking. And that was certainly inspiring, this to see that we could actually make huge technological process. And since I've been involved in energy for over 40 years now, I've seen how electricity technology has evolved very little and very slowly by comparison. And I think we can do much better. And I think that the technologies we need to do much better already have been invented. We don't need to invent new technologies. We just need to apply things that have already been created in new and innovative ways. And so a key for this is to start from the future and work backwards towards the present.
Like that. Yes. Okay.
So when the people who developed internet technology started, one of their very first networks had 4 nodes on it. 4. And then they developed a way to do communication, and they incrementally scaled up from there. So they started small and scaled up. And most technologies work that way. The first airplane was 1 person, 12 seconds, 80 feet, or I guess 20-something meters. And now we have jumbo jets. So that's how technologies generally work. And I think electricity technology will work the same way. And to be clear, my focus is inside of buildings and how the building relates to the grid. I do not attempt to make claims about how the utility grid should be structured, although I have thoughts about it.
Yes. And about 60% of the energy gets consumed in buildings, electricity, if I'm not mistaken, maybe even more.
Yeah, I think in the US, it's something like that. Absolutely. And as we electrify more and more of buildings, that may increase. But in any case, it's a huge amount and growing. And also the same technologies will apply in other sectors like industry, agriculture, and also transportation.
Are we then talking about one, of course, the energy efficiency? They can produce the same thing with less energy input. But are we also talking about flattening the load so that it becomes... So, I mean, I'm just still trying to understand the linkage between what happened on the internet side of it.
Yeah, so for demand flexibility, shifting and very occasionally shedding load, the goal of that is to make better use of infrastructure, mainly the infrastructure of the grid in terms of generation capacity and transmission and distribution systems, but also the infrastructure inside of buildings, and enable use of more renewable sources by better meshing demand to the variable renewable supply. That's been well understood for a long time. People who have little or no electricity today in perhaps Southeast Asia, Sub-Saharan Africa, other places, off-grid and such. And hundreds of millions of people on the planet today own one electrical device, a mobile phone that they charge with USB, just as you and I do. How do these people with very little money have access to great technology? Because we all use the same technology. And what I've come to understand is the best things in life are simple and universal. And it's the worst things that are complicated and are different for no good reason in different places. And our communication needs in the United States are not different from the communication needs in other countries. And so it's no surprise that we can use the same technology, the internet, for communication. And electrons are all the same. and we do the same kinds of things with them. So there's no reason for electrical technology to be different in different places. If you imagine an off-grid household with a solar panel, a battery, and a few devices, the generation is variable and the people's needs are variable. How do devices know when it's best to consume power and how much to consume to properly balance supply and demand? And for people with very little technical background, these things need to be automatic, and realize that you could use price as a way to measure the availability of power at any particular time, both in relative and absolute terms, so that devices could decide when to operate and how much to operate. And this would make a household work well. And then, if you imagined several households or small businesses in a village, you could connect them together with point-to-point connections, and they could exchange electricity between them, because when the price of electricity in one was enough higher than another one, they might usefully decide to exchange power because it could be mutually beneficial. And then you could have flows of power automatically through such a network with no configuration, no central control. And then if you imagine some number of years later, a grid connection comes along. Maybe it's a reliable grid connection. Maybe it only works intermittently. It doesn't really matter. And you could then have prices from that grid connection to this network. And so you can start using the same mechanism at all scales. And of course, in wholesale energy markets all over the world, we make great use of prices. And the internet protocol is independent of scale, and it's independent of the complexity of the or topology of the network. That's why it can scale to billions of devices and over the entire globe.
But as soon as you leave the house, you will need the local distribution network.
So the network, there's a network inside of each building. And I tend to say building rather than house because it should be generic to any building type, not just residential. And that could work autonomously or connected to others. But if you have a larger network, then you could exchange. And there's no limit to the size of such a network, and also no limit to the amount of power you might have on these power links. That's a result of just the particular physical layer technology, just as the amount of data we can send over an Ethernet or Wi-Fi link depends on what version of Ethernet or Wi-Fi we're using. Concepts can scale as our physical technologies expand.
So how does, say, office building with, 3,000 people inside, maximum demand about, say, a couple of megawatt, how does it look like inside?
Yeah, so in an office building, there's a lot of uses that probably would be relatively invariant to price, such as lighting or IT equipment and such. But the heating and cooling systems could vary their behavior, and you could have thermal storage to shift load, and when prices get very high, shed some load. When prices get very high, you could dim the lights. Water heating, which is, of course, not very big in an office building, can be flexible. And then, of course, we will have electrical storage in more and more places inside of individual loads. There's a company in my town that builds an induction stove with the battery.
But it is amazing.
Yeah. And if we think about where does data storage exist on the internet, it exists everywhere. Computers have storage, network equipment has storage, we have storage all over the place. And we will have electrical storage all over the place. How much we have in different devices is an empirical thing product manufacturers will determine. But we'll make good use of storage so that we can have more loosely coupled systems rather than tightly coupled. And one thing that this does is it makes microgrids inexpensive because it's just a natural property of the technology. It's not something you add on to it. It's just that any given what I call a nanogrid is inherently has the ability to be autonomous. In fact, a notebook computer is a nanogrid because it operates grid connected or off the grid, and it's a grid because it distributes power to attached USB devices. So that's an example of the seeds of this that we already have today. We just need to take these things, add a few more things like the price, and start scaling.
I'm just thinking, how will that price work? I understand the concept. This is brilliant. Yeah, I think that's what the world should head towards. But if the batteries and the storage become cheaper, then there is no price will not vary by time of use.
If you're connected to a utility grid, probably there's always going to be some amount of non-renewable generation.
The batteries will flatten that curve, no? The way the world is, where we are going.
Yeah, some people talk about electricity being too cheap to meter. I'm skeptical of that because past promises that didn't happen. But it doesn't matter because even if the price goes down, there still is always a price. And there's always capacity constraints. So managing capacity is also an integral part of this. And so that doesn't really, I don't think it changes the value of doing this.
Now, but let's look at this two point that you made, that always capacity is constrained and the price is always going to be there, because I have a personal situation. If I was in my house in Melbourne, I have excess electricity. Sometimes the grid don't take it. So it's negative cost to me. So I can do something else. So, but once you charge your cars and a home batteries, still excess. What are you going to do? Of course, I will need in a week's time, maybe when the sun won't be there. But if the battery price becomes $10 a kilowatt hour one day, I might have, I don't know, 400 kilowatt hour in the house, then I remove that problem. So in that world, how will this work? Why do I need a price signal? Because electricity is too cheap to measure, as you said, one could say.
Yeah, I guess I'm not convinced that electricity is going to become too cheap to meter. If you take the advantage of your office building, office buildings have very limited roof space if they're tall. And so they're always going to be importing electricity from somewhere else. And that's always going to have a price. And we have to pay for the transmission and distribution systems.
But these are all
somehow.
fixed fee. But what I'm saying, our problem was, society's problem was, supply demand need to be matched at the same time. And that's where the price variation came in. And plus the cost of input was different. If it's oil, it's more. If it's a coal, depending on where coal. But those differentials are gone if we go into large scale wind and solar in a way. And if we have batteries, then the delta, and even hydropower, the delta is not much, right? There's no delta. It's a flat. Doesn't matter which time of the day you release water. It's the same, more or less. So is solar. So is wind. I'm just arguing to understand.
Yeah, I hope that we get to a point where electricity is too cheap to meter, but I'm not going to rely on that. I want to make sure that we have technology that works in any case. But for my house, on an annual basis, excluding my new EV, before I got an EV, my house was net zero, but in the summer, I export tons of electricity. But in the winter, I need lots more electricity that I can generate. And for the foreseeable future in California, we will, in the winter, electricity will have definite cost. And so we'll need to balance supply and demand, and we'll need to manage capacity. And in terms of how this microgrid operation can then extend to the grid, we need to have utilities charge prices that are change at least hourly and are different every day, because conditions on the grid are different every day. And if the price is not different every day, it's the wrong price. You get the wrong result. As a child, I learned garbage in, garbage out. If you have bad data, you get a bad result. If you charge good prices, then the grid can charge prices which can shape customer load to produce the best possible outcome for the grid in terms of meeting all its goals, minimizing costs, addressing capacity constraints, and such. So we need to get to have that be the universal mechanism where at every meter on the planet, we charge prices that change at least hourly, maybe it's half hourly, maybe 15 minutes. I don't think we'll ever get to 5-minute retail pricing because I don't think it'd be worth it.
We have 5-minute pricing in Australia, wholesale market price.
Wholesale pricing, not
yes,
retail.
but not at the residential retail level, yes. But
I
those
think
people who wants to sell their excess battery to the market, few companies are providing that you can take that risk, then I guess technically you can get exposure to that 5-minute pricing.
Yeah, the purpose of prices is not for people to look at. Prices are for machines to look at. We don't want people to look at prices. They have better things to do. They wouldn't be good at using them. I don't know anybody who's going to get up at 3 o'clock in the morning and change the set point on their water heater. These things have to be automated.
Yes.
And the automation really doesn't care what the time periodicity is. So we can decide how we move from hourly to smaller time increments in future years once we get this established. And that's just an empirical question about what time interval is worthwhile. But as we get more storage, both on the grid and in buildings, the need to have smaller time intervals declines. And those two things will meet and we'll come to some And the time interval doesn't have to be consistent from place to place, so long as the general mechanism is consistent.
So these IoT devices, lack of a better word, which is also a different type of meter. So what would be the incremental cost to a system, say in a household level, that you're thinking of?
So many appliances today are shipped with Wi-Fi as a basic feature. And one of the reasons for that is because the integrated circuits, the microcontrollers commonly used in appliances, commonly come with Wi-Fi on the chip as Bluetooth. So it's essentially free. There's no serious incremental hardware cost for adding Wi-Fi. So it's just a matter of code. And if you have lots of appliances, a lot of the code you write, you can reuse for all your different appliances and all your models. And so it's a relatively low investment. Like I remember in 2018, LG announced that all of their dishwashers would have Wi-Fi starting in 2018. I don't know the dishwashers need Wi-Fi, but it's so inexpensive to include it that it's there by default. So once you have the communications, you by definition of computation, in which case you then have to add just a little bit of firmware to receive and to use the prices. And so it can be a zero hardware cost and a fairly modest engineering cost to write the software code to use the prices. And if it's prices, prices are the same worldwide. We have different currencies, but that's not so important. But it's the shape of the curve, which is the primary importance. And so you can write the code once, ship globally. And if we have the same communication protocols globally, you only write that once. And so it can be a relatively low cost mechanism. And with prices, there's no configuration, there's no coordination with third parties, there's no valuation in the wholesale market. There's enormous amounts of simplicity. And the competitors using pricing are all very expensive and they have performance capabilities that they simply cannot do the things pricing can. For example, microgrid operation. When the grid goes down and you lose your internet connection, how do your appliances know what to do if their brain is in the cloud? They won't. But if their brain is local, they don't have to know or care where the price came from. They just only care what the price is.
Interesting. Yeah, that would be hugely, you create a lot of values even within a commercial building or in a household. You basically optimize within it. You almost, if you follow like a hydropower does, they have an operational rule curve by seasonality. They know this is how we generally operate, even without external price signal. So could be almost a seasonal rule curve within the house that machines can decide what time the fridge comes on and dishwasher comes on. You just turn them on and keep it there, and the machine will decide what is the best value for running this within the household or within a commercial building. Yeah, I can see that. Huge value.
Exactly. The purpose of devices that people buy is to produce the most value for the person they bought. It's not the purpose to produce value for somebody else, whether it's the product manufacturer or a third party. So I'm a huge fan of the term customer energy resource from Australia, and I'm trying to popularize that in the United States to remind utilities that these are customer devices, not utility devices.
We can clearly see the ramification for the vehicle to grid because it's a big battery, big resources, and but the same thing can apply at a micro level, whether it's for a television or a fridge, right?
Yeah, exactly. So I own two grid responsive devices today, and I got both with a free software upgrade from the manufacturer. My phone, about now 2 years ago, got a software update. So when it charges, it gets a 5-minute greenhouse gas signal and optimizes to that. And if that was a price signal instead of a GHG signal, the communication and the optimization would be exactly the same. And then I have a heat pump with a very smart controller. And that controller used originally when I bought it, optimized to TOU prices in the cloud. And it got a free software upgrade about a year ago. And it now optimizes to hourly prices inside of the controller, inside of my house.
Wow.
I can't yet pay hourly prices, but in California, we are planning to introduce them soon. And so once they're available, then the largest load of my house will then optimize to hourly prices with no new hardware.
Yeah, I can now understand sitting in front of a fan. This has got a built-in battery. It can be operated with Alexas of the world. So it has the communication. You just need someone in the front which can optimize all of them, right? This is how we should operate as a collective.
Yeah, so ideally, devices optimize themselves. The vast majority of devices out there in the world can't take in prices, so we will have a lot of external controllers or central building systems or cloud-based optimization to send control signals to devices, and that's a necessary part of the transition. But over time, more and more devices, when you buy it from the store, it will come and it'll be automatically price responsive. Plug it in, and this sort of raises the question of what's the mechanism by which price devices get those prices. So we now have the protocol OpenADR3, which is the ideal mechanism for communicating such information, whether it's inside the utility grid, from the grid to the customer, or inside the customer site. You can use the same protocol for all of them, just like we use the internet protocol for all data communication.
A lot of thinking, yes. Amazing.
A few months ago at Lawrence Berkeley Lab, we set up a simple prototype hardware and used the MDNS protocol, which is how computers discover printers on your local area network, so that a device automatically discover the local price server on the LAN and start receiving prices with no user input. Now, you do need to connect the device to the Wi-Fi network, or if it's Ethernet, you just plug it in, and then it can automatically find the source of price, start getting them, and start using them. Zero user configuration. Plug and play, that's the way IT devices work. That's the way electrical devices should work. High expectations for technology, not our current low expectation.
Yes, especially also emergency responses or something you can just say, like what happened in Tokyo after the tsunami, they reduced the demand dramatically by asking people to voluntarily do it with the price signal. But here you can just tell the machine, take 1,000 megawatt off, and the system can decide and what signal to send, and can happen super fast, right?
Exactly. We can do a lot through pricing. We can also send out emergency alerts, which would
Yep.
generally be a non-financial. So in California, we routinely in places where there's fire risk, and there's a lot of fire risk in California, utilities will send out signals saying 6 hours from now, the grid may be down for 2 or 3 days because of the danger of fire. And so then batteries can charge up, vehicles can charge up, HVAC systems and water heaters can do the most they can before the power might be shut off. And that's a non-financial signal, but it still can inform devices how they can automatically do their best, provide the best service for the customer in case the power is shut off.
I mean, like my Tesla Powerwall does, takes the weather forecast and send me messages saying I'm supposed to not fully charge today based on the time of day, but there is a weather forecast, there may be a typhoon coming. So can we fully charge now? This is an AI picks up, but exactly similar. If all the appliances could do that, that's a hugely value.
Yeah, and then devices should also be able to take other kinds of information, such as if you're going to be on vacation, then the water heater can change its operation, and the climate control can provide you the most value. And if you do the optimization locally, you don't have to tell anybody else that you're on vacation. And privacy is really important, and pricing is the best way to preserve privacy and cybersecurity.
Yeah, this can be going to the home robots job to optimize all of those, no?
Yeah, they can charge and operate when it's the best time to charge. Also, presumably, you'd want your home robot to maybe not do noisy things when you're trying to sleep.
Wow, you have been thinking a lot, Bruce. What else you do other than thinking and working on these things for fun?
Oh, for fun, I like to garden. I like to go on my bicycle rides with my regular bike or my e-bike. So again, electricity and transportation are increasingly important. I recently got an electric vehicle, and as many people have discovered, it's a lot more fun and satisfying to drive and quieter than the old kind. So the vehicles are actually, that's a great example where for over a century, we had relative stasis in our technology of the internal combustion engine. And then we are on the path of transition to a completely different technology where the vehicle does the same thing, it moves people and goods from place to place, but the way it does it internally is completely different. So with electricity, we need to transform our technology and have it provide us the same services, only more, but do it less expensively and do it better.
Yes, like electric vehicle, I was explaining to someone who ultimately bought one, saying this is really don't compare with your car. This is not a car. This is a computer with wheels. So you can do so much more. As a computer, you can take your Zoom call, you can listen to this. Since you will have AI in the car, and it's a different experience, right? And it's a big battery. You can connect to your appliances today, tomorrow your house, day after tomorrow maybe the entire grid. A friend has a problem, power failure, you might just go saying, okay, I'll come here, leave my car to your house, and I'll take the train. Before you could not think along those terms, but it's different. It's a computer on wheels, right?
Yeah. And also for the vehicle to grid issue, how do you know when it's worth sending power to the grid? There's the whole battery degradation possibility. There's wanting your car to be fully charged. And so people's preferences vary from day to day, and how much money they might get from exporting the power is going to be critical, because if it's not enough, then they won't do it at all. And if it's a little bit, they'll maybe discharge a little bit. If it's a lot, more people will do it. So price is a way to orchestrate demand. And airlines do this every day. Airlines don't charge for seats based on the cost of running an airplane. They want to fill up the seats and maximize revenue. With electricity, we want to fill it using the renewables and the capacity and minimize cost. And so prices are a control signal, that as opposed to something that you can derive from the wholesale market.
Yep, absolutely. And then the car, the point that you make, I forgot, I posted on LinkedIn. I was looking at a study which basically say that with the V2G enabled right now, based on what the Australian prices and the fluctuations are, if your car is V2G enabled, your lease payment could be 30% less picked up by the car's revenue. And the calculation they were using, if I'm not mistaken, if your lease payment was about $800 to $1,000 a month, the V2G could give you $250 to $300 equivalent value.
I don't doubt that. I do expect that as more vehicles come online to potentially do that, the value that they will get will drop.
It will drop dramatically. Yeah.
Yeah. And which is fine. That's the way it's supposed to work. It should drop to the point at which we balance the supply and demand of that injection of power into the system.
Yeah. And then before that happens, all the sort of CCGDs that sits there and the combined gas plants to take a few hours in a year or a month to take the peak will go. So those expensive plants will go. So eventually, even the fluctuation in the wholesale market price will be much less than the sort of daily fluctuation, right? Because those things will go, because the EVs can, or the virtual energy network can pick up those things.
Exactly, because a lot of the fluctuation in our wholesale price is due to the fact that demand is relatively, but as demand becomes more variable, then just as you said, the wholesale price should become less variable.
Yeah, so a lot of fun happening in the future, yes.
So an important factor about V2G or for exporting excess solar is that in many places, like in California where I live, it was common to have net metering where you got either the same price for exporting or maybe even more. As more and more customers are exporting, then more and more utilities are having differential prices where the export price is lower, usually significantly lower than the import price at the same time. So if a customer might be buying electricity at 40 cents, or if they're exporting, they're only getting 10 cents, then what's the marginal value of power now within the building? It's either 40 cents or 10 cents, or maybe if it's 25 cents, then it keeps the building from neither importing nor exporting. So if the water heater, for example, is trying to decide when to operate, it should operate as much as it can during the time when you might otherwise export at low value, because that's 10-cent electricity. That's much cheaper than the 40-cent electricity it might if you were importing. So that creates what I call a local price. It's local inside the customer site in the same way that a local area network is inside the customer site. And so that the value of electricity inside the customer site can diverge from the price at the meter. And there are at least 6 different reasons why that's true. And this is not a problem for price responsive devices because they don't care where the price comes from. But if you have external optimization and you're only optimizing to the retail price, as an aggregator might do, you will commonly do the wrong thing for the customer because you don't know the actual context inside the building. And this is a terribly important point, and one of the reasons why pricing is a much higher performing for the customer mechanism than alternatives, which can't take customer context into account.
Yes, but also technology-wise, like comparing with internet, we had this. I used in the mainframe that 8-inch floppy drives. Remember those days? 640 kilobyte or even less. Then came 1.44 megabyte, then 1.2, and then
Well, it started with paper tape.
oh no, paper tape I've not seen.
Paper,
Seen the punch card.
I used all those things.
Okay, so from those days, now you can have a multi-terabyte on a tiny flash drive or even a card for your camera. And plus the bandwidth of you and I talking now, I don't know how many megabits that is per second, right? So all this change, storage change the IT world completely. We have a video, 4K video on a phone. This was not possible without the storage. It was unthinkable when you were using the tape that one day you'd be able to carry that much store. It would have taken an acre block to carry that much store. So on the energy sector, God knows how magically, if we could store a megawatt hour in a house, what will happen?
Yeah, I mean, there are certainly laws of physics that are going to come into play, and there are real laws of physics limits in addition to the technological and economic limits we will run into. And I think that those will come sooner for electricity than they did for communications. But we will certainly see a lot of progress. And just as in a computer has many different kinds of storage inside of it. It's got registers, it's got level 1 cache, level 2 cache, it's got solid state drive, cloud storage. I think many electrical devices will begin to have multiple storage technologies, some optimized for less than a second transmission, some for minutes, some for days. So we will see this range of storage technologies also. And again, price can help mediate amongst those.
Yeah, but isn't somehow, I'm just thinking loud here, computers started with a local storage and gone to the cloud. But looks like electricity is starting with the cloud storage and going locally, no? Is that a fair comment to say?
Yeah, with computers, you can move data at lightning speed. Electricity, you cannot move massive amounts of electricity at lightning speed, and there are losses and costs. There are many analogies between the network internet technology and electricity, but there are also ones that are not apt. So one has to be careful in correctly applying the analogies and not incorrectly applying.
Thank you for that connection, but it's interesting to think that way, that cloud computing came later, that everything's in the cloud, but we're so used to that one-way travel, like a water supply system. All energy, all water is somewhere in the reservoir at gravity flow in one direction. Electricity used to be like that, right? It's centrally stored, gravity flow. You have no choice. Either you take it, if you don't pay, we'll disconnect you. Now suddenly people like yourself putting a solar, generating electricity and selling one to sell back. So giving the utilities a lot of headache, of course.
In terms of making the thing simple and universal, it's clear to me that between the grid and the customer, there's really three domains of coordination that need to occur, and they can be mostly or entirely separate. And those I call energy, power, and capacity. So energy is amounts of energy, and we do that with pricing or with other mechanisms, but hopefully mostly with pricing. So that's kilowatt hours at the meter. Power is the amount of capacity you need, amount of kilowatts, and there's always a capacity constraint in any wire or any piece of equipment, and we always need to respect those. Now, in the past, we've typically overbuilt systems, have wires much bigger than we need, and transformers bigger than we need, and just make sure that we, on an annual basis, never get close to exceeding their limits. Or we have circuit breakers that just trip, and then you're suddenly without power. But coming back to your notebook computer, when you plug a device into your computer, it doesn't just get power through the USB port. It has to request capacity. And this feature of USB has been present from day one. And USB has been around for a third of a century, which is remarkable to think about. A third of a century now. We've had capacity management for electricity in devices we all own. So in Australia, you know about dynamic operating envelopes, where feeders could have too much excess PV, so the utility coordinates with customers digitally and automatically to limit the maximum export, make sure that distribution system limits are not exceeded. And that's a wonderful innovation, and I'm all for it. But everybody sees the same sun, and so you can have a system that's where you just broadcast on a one-way basis limits, and it can work well. Now, in California and other places, the more urgent issue is with EV charging, whether it's from EV charging for residential customers that use a transformer that may serve 10 customers. And if too many of them want to charge a vehicle at the same time, it could overload the transformer. Or from EV charging stations, very concentrated load. And traditionally, what utilities do, they say, okay, what's the maximum you might ever consume? And then we'll add a 25% safety factor. And we have to guarantee that all of the time. And that's very expensive. If we had freeways size to the maximum demand for freeways, they would all be 12, 16 lanes wide, and we couldn't possibly afford or want that. But if we digitally manage capacity, then we can allocate capacity digitally so the customer devices and building don't exceed those limits, and we can allocate it through various mechanisms to make sure that wires and transformers and other equipment are not exceeded in capacity so that we can fully use all the capacity we have and guarantee to the utility as they need the capacity limits will not be exceeded. And the third element is what I call power, which is things that inverters do. I'm not an electrical engineer. The people who work on inverters seem to have that well on hand. And so that's its own coordination. So again, energy, power, and capacity, three different problems with three different sets of solutions that can all operate in parallel.
Fantastic. But how do you bring everyone together in this? Because where California is, where Melbourne, or actually all of Australia is very much ahead than rest of the world. I did a lot of work across Asia. Still, people are struggling. Should we put my solar in or not? Still, a lot of electricity are generated using diesel gensets at 40 cents a kilowatt hour or even more, because there's a pilferage involved that maybe another 20 or 30 cents, the inventory get lost. So how do you bring everyone in with the technology, no?
Yeah, so there's the technology and there's the product. So one thing we need to do is we need to get the technology right and then embed the technology in products. And then over time, as people replace products, then they can start using the better technology. And that's how we deploy internet arc technology. We didn't do it all in one day. We did it over several decades. I first used email back in 1978. I first used Ethernet back in 76. And we need to first get consensus on the technology so that manufacturers can have the confidence on what they should put into products, so that everybody puts in compatible technology. We start shipping it globally, and then as people replace products, they own more and more products that can utilize the new technology. Just as my heat pump controller got the software update to be able to take in prices, so that when the prices become available, we start using. So for pricing, the key things you need are for utilities to charge the prices, infrastructure to distribute them, and then loads to use the prices. And manufacturers of products will be reluctant to offer price responsive devices until they see that there is enough customers who can pay such prices to make it worth their while. And so in the United States, there's very few people who pay hourly prices, and so the manufacturers haven't wanted to do that. In contrast, in Scandinavia, most people pay hourly prices that are different every day already. And there are retailers in at least 20 countries that offer such prices. And why do people switch to these tariffs? It's because they result in lower bills, which is no surprise. So that's the secret to success, is for utilities to offer people tariffs that can allow them to pay lower bills. by shifting load. And then when the tariffs are available, there's going to be more and more technology that can use those prices, and we get a virtuous cycle that just increases the amounts of savings every year.
Yeah, I can also see somebody coming up with a gizmo that you should be able to retrofit some of the existing devices, just add something in front. I've seen things you can buy in the power plug and that can control, switch on and off, and also measure how much electricity is flowing through. And these are $5 equipment for TV or other things. And then maybe if the utilities like it, rather than providing a simple time of use tariff, which is just a block, they might provide you different tariffs for your different appliances if they could, because you have essential appliances in the home, but there are also discretionary appliances like your heat pump and the domestic hot water that can switch off anytime it need. And with that flexibility, rather than having a one time of use tariff, you might even have a half a dozen time of use tariff within the household. I'm just thinking, then whether people have a wholesale electricity market or not, still central planned economy, they can still benefit from that optimization, no?
Yeah. So one thing to remember always is that the electrons are all the same. If you go to the supermarket and there's tomatoes, the person at the checkout doesn't ask, are you making salad or are you making pasta with the tomatoes? They're just tomatoes. There's one price. So there's no logical reason why there should be different prices for different end uses. Now, I can imagine on a temporary basis as a transition to charge more dynamic prices, let's say for EV charging, on the way to charging those prices for all loads. And the reason for that is to make people more comfortable with the process. One thing it's important to remember is charging different prices does not raise the cost of running the system. If anything, charging better prices is a way to reduce the cost of running the system. So charging different prices shouldn't raise average bills. It should decrease average bills because
Yep.
then people will start having an incentive to have better load shapes. So there are places where utilities have offered tariffs for end uses, but that should only be done on a temporary basis as a transition, and there should never be any hardware installed to do this. It should all be done such as with devices self-reporting their consumption, because we should just move to the better prices for all devices after a few years as people become comfortable with it.
Yeah, but not many countries in the world that have dynamic pricing in the network. It's a flat fee. People pay one single tariff. Even time of use tariff is not everywhere. Of course, California and Australia is very advanced.
Yeah, when I was a child, the phone in my house was black and had a dial, and it could
Yep.
only make phone calls, an analog device. And now I have a smartphone. Technology changes, and it's uneven as to how it comes in, but we can recognize what's the future. Like
Yes, absolutely.
when the iPhone came out, I didn't have 3 years for me to get one, but I knew that eventually I would get one. So if we have better technology, we can know what it is and then figure out what's the best path towards there. And it's not everybody jumps immediately to the better future. It takes time, different places, different customers, different devices, but we can just move towards the better future at the most efficient and workable pace.
But the adoption also, the technology leapfrogging, as I'm thinking of, is it possible to use that technology rather than waiting its natural adoption of 7 or 8 years or even decades that it takes to trickle down to the developing economies, these technologies from the developed world?
I don't see that this is something which can be used. Pricing is the least expensive way to do demand flexibility, so it should be the most accessible to places with the least resources, right? Like in California, we're relatively wealthy, and so we can afford to spend more money on things like aggregators, and which are better than not having them. But in places with less money, they shouldn't do things like that. They should move more directly to the most cost-effective solution.
And I agree to that, but I just thinking that how long it will take, and some of the utilities may never have a wholesale market equivalent prices. So where this can benefit from those areas as well.
Oh, I'm confident that eventually this will become universal. Now, it will take a long time. Like where I am, we still have analog landlines as we
Yes.
did when I was a child. I think in other countries, they've completely gotten rid of that. In California, we still have some. Some of these things hang on, but they're just a very small percentage of people. The vast majority of people have moved into the future.
Yes, and absolutely, absolutely. So yeah, the mobile phone is an example. I'm an early adopter. I bought my mobile, I think in 93, this Nokia mobile. It cost me arm and a leg. And I had that. And people say, what's the use of that? And someone actually argued me, can you give me a list of 10 things you will do with this? So why even bother? And now everybody has multiple mobiles, right? So the world has changed.
Yeah, and that's a great example because actually the United States was relatively late to adopt mobile phone technology, not because we couldn't afford it. So the relative sort of income levels of different countries is not determinative of how fast they will adopt the better future technologies.
Yeah, that's a long discussion.
Yeah. So I think the key thing here is where I started out was I start from the future and work backwards towards the present. And I assume that we are at the beginning stages of a transition to a technology basis, just as internet technology did. What I find is the vast majority of people who work in the electricity space, they start with the technology we have today and they say, how can I make one small incremental change to the system and to make it slightly better? And then the next year they do another small change, or the person next, the office next to them next month does another small change. And if you take this tiny incrementalist approach, it's extremely slow and you may never get to the better future. An informative anecdote is that in the 1950s, at least in the US, Bell Labs, the phone company, research institute was thought to be the premier research institute on the planet. Maybe just in the United States, we're very parochial in that sense. And multiple people went to them and said, hey, there's this new thing called packet switching. We think it's the future of communications. And they said, we know of that. We know it cannot possibly work. Therefore, we don't need to study it. And they completely missed internet technology. They invented digital phone lines, which are awesome at what they do, but they're only digital phone lines. They're not network connections. They could not invent the better future because they were so trapped by their 19th century technology. And most people in the electricity space are trapped thinking that because 140 years electricity technology has not changed its fundamentals, never will. And that's a completely depressing point of view because I'm an optimist. I think we can have much better technology. And in fact, we all own seeds of that today in the form of things like USB, which digitally manage power.
Absolutely. Thank you so much. Is there anything else I could have asked you? This is fascinating. We can
Yeah,
continue
so
on and on.
there's one other area of this that is always there on the side, which is direct current power distribution.
Yep.
Some people are familiar with high voltage DC. That's not what I'm talking about. I'm talking about DC power in the building, such as USB and Ethernet do every day in products that we own. If we were starting from scratch, we would use both AC and DC, but we would use a hell of a lot more DC. And probably most things in buildings, maybe even all things in buildings would be DC. Maybe we would still use AC on the grid. I don't know. So we need to start making a lot more use of DC, and that's another topic. But that's also part of this picture is to mine that opportunity.
I'll come back to you on that because I wish I had met you a long time back because I was doing a project in Afghanistan at the time. We piloted into multi-countries, what I call electricity in a box with basically a battery, solar panel, all DC appliances because my TV is DC, everything is DC, fridge, even air condition with a heat pump. These are all sort of variable speed motors, right? So my view was, let's do everything DC. We'll get the equipment so that there's no losses. That automatically make things energy efficient because I can get a 32-inch DC TV. I think I got it to 28 watt. But if this poor person buys somebody's hand-me-down CRT television, 350 watt, that sort of destroys the project because we allocated only 28 watt for the TV. It's a whole new discussion. I want to have a whole conversation with an expert like yourself. If you have the time, maybe we schedule another discussion. What is possible with 12 volt DC in a house?
Yeah, actually, I would say nominally 48 volts is a sweet spot in addition to 350 volts.
Yeah, I mean, 66 and beyond, you can die from electrocution because if it is below, then you don't need an electrician in the house. And USB-C can do up to 100 watt. So that was my view, that why can't everything be connected with USB-C, and we limit appliances for developing Asia below 100 watt.
Yeah, USB-C actually goes to 240 watts. Although they're both optimized for high-speed data, we really need a DC standard optimized for power that also includes data. That's part of our follow-on discussion. And if anyone listening to this wants to find out more about what I do, if you Google my name, it's not a common name, you will find me. So please.
Thank you so much, Bruce. Really appreciate your time.
Thank you. Likewise, this has been a pleasure. I look forward to continuing the conversations.
Thank you. We hope you enjoyed this episode of Energypreneurs. If you enjoyed this, don't forget the full video is on YouTube. Just search Energypreneurs. Thank you. See you next time.